Welcome back everybody to Sober Builds 3D. Today I'm going to show you how to go down to the hardware store and buy a nut and bolt. No, we're going to make one so you can skip the store if you need one in a hurry. Let's go. Alright, so we're back to the same program again, Onshape Online. We're going to do a sketch, and in this very center of the sketch, on the top plane, we're going to do a circle center point. Make it whatever size you want. This is kind of what I like about this. Whatever size I want to fit something, I can make it. So for this test, we're just going to go 3/8, 0.375. And then I'm going to do another circle around it, 0.5. And that's going to be the head of my bolt. Now these, for printing bolts for me, I don't want to have to get out tools. I want to be able to use my hands to tighten, loosen everything as much as possible. And there's probably many different ways of doing this proper. I haven't lived 37 years of my life doing things mostly proper, so this is no different. I'm going to make this bolt thread whatever size I want. I'm going to make the nut whatever size I want to match it. I don't know if any of the numbers even make sense for what they are, but it's what it creates and it works. So here we go. So you're going to have that top sketch, and then we're going to do an extrude, and I don't want to do the whole thing 1 inch. I want the head of I want the grip that I have to be a 1/2 inch tall. Yeah, that's probably even a little bit too much. Let's go 0.25. We're going to go 0.25. Extrude that, and then we're going to open up sketch 1 again and extrude it, the center this time. Accept that, and now right here, this is a plug-in that you have to install on Onshape, but you have threading, thread creator. I'm going to create a thread on the outside of that diameter that I just set up, and as you can see, it's already throwing a thread on there. But this is what I like. This is a 3/8 thread right now. But I can make that pretty much whatever I want to make it possible to print it correctly. You want at least a 45-degree angle. Anything beyond that, and that material can't hold up to that angle typically unless you use supports. If you use supports, it really doesn't matter. I don't want to have to peel supports off of this, so I'm making it as close to a 45-degree angle with those threads as I possibly can, and I'm doing that by eyeball. And again, there's probably a better way to do that, but this is how I know how to do it, and it works. So that is how I'm showing you, and I will watch anything you send me on how to do this properly. So if there's better ways, which I guarantee there are, and you know it, just send them my way. But we already have a thread, but I want to make this whatever I want. So I'm going to go to pitch up here, and I'm going to go 0.08, and we're going to see what that says. Well, that looks like a lot probably stronger of a bolt itself, because it's just a lot thicker in the center. And it looks like I'm still holding on to about that 45-degree on there. So I don't want to go fully threaded. I only want to go a certain distance. We're going to go 1/2 inch. We're going to see where that brings me. Oh, that was the wrong one. So we're going to go thread length of 0.5. And that leaves me some of my bolt unthreaded. And that'll probably be what fits through whatever piece this goes through later. So now I have a thread, 0.08 pitch. It is a 3/8, 12.5 right now. Now for strength, I am going to add a fillet down here, right where they meet. And 0.05, let's go 0.06, just to give it strength. If you have a straight wall, and this is something I've learned through my job, anything coming straight down onto a surface is more likely to snap off at that point. If you radius that, or put a fillet on that, it has more strength there at that corner. So I add a fillet there, and now I essentially have my bolt set up. Now I want to just be able to take this end right here, and I'm going to do a sketch on it, and I'm actually just going to basically give myself something to be able to grip. I'm not going to go with the T-handle on it. I'm going to keep this one round just so it's an easier print. But for myself, I do a sketch right on that center plane. I'm going to be on the bottom of this now, and I do a line right from the center, and I come up to the top. Again, this is just how I've figured out it works. I don't know anything about concentric, coincident, parallel, tangent, horizontal, vertical, perpendicular, equal, midpoint, none of that. I don't know what it all means as far as drawing and designing. I know that a lot of times my parts go, oh, that's not going to work, and then I print it and it still works. It just doesn't like how I draw because I draw with crayons and this wants me to use a very nice pen. But, so I'm going to take that center point now, and I am basically just going to draw a line off that center point straight down, and I'm going to go 50 thousandths. And then I'm going to go straight up to the next edge, and I don't really care what this angle is. I'm just trying to give myself something to cut out so that when you're trying to work that bolt, you have something to grip. So I'm going to go straight to that corner, and then I'm going to come up here, select my center line that I drew, and I'm going to mirror that over. Now, if I accept that sketch, I now have two pies here, which should only be one, but with the fact that I drew this center line, it's splitting that into two parts. That doesn't matter. But I'm going to go back to that sketch. I'm going to highlight both of those lines that I drew, and I'm going to come up here to circular pattern. And right now that is revolving what I just did around 360 degrees around that surface. I want, let's say, 8 of those little cutouts for grip. That all of a sudden there's 8 of them on there. Accept that. Now I'm going to just click sketch 2 because it is highlighted at that point. I'm going to hit extrude. That's probably not going to work. Nope. But under extrude, I can select those surfaces that I created. And again, there's probably an easier way. If there is, I'm willing to learn it. But right now, for what I'm doing, this is getting me everything I need. Now, once again, extruding is trying to go positive. It's trying to bring those up. So if you can see them little triangles, kind of looks cool, but it's certainly not going to work for what I need it to do. So I'm actually just going to do a remove those, and then I have to reverse it so it knows to remove it through the part. And there, now I have little spot with grips on the end of that bolt. So now we're going to come in here and make the nut for this. I'm going to go to the top plane, sketch, and make sure I'm clicking on the very top of that bolt. And then I'm going to do an inscribed polygon. And I'm going to make that 6-sided. Click, and I'm going to make that a 1/2 inch. And then right in the center of that, I am going to go 0.395. And the reason for that is because my stud itself is 0.375. I know that I have about 10 thou worth of shrink or tolerance that I have in this material with how it flows. It'll close up a hole a little bit, so I've learned that I have to go about 10 to 15 over right off the bat. Sometimes 7, it just depends on the material. But right now, I'm going to go 20 thousandths oversized only because, from experience, I know it works. So if you were to do this, I would have very high confidence that you would have success doing the exact same thing. So I have it at 395, 20 thou oversized right now. We're going to go ahead and accept that sketch, and then I'm going to extrude once again. I'm going to go backwards though because I want to see how it's going to work. And I'm going to go 0.25, and there you can see the actual nut that'll go around that bolt. Put the bolt back on, boom, there it is. So now, simple thread creator, I'm going to thread the inside of that, and I'm going to go back to pitch, 0.08, to match what I put the pitch on the bolt. And there you have a nut and a bolt. Okay, Now we're going to come over here to Orca Slicer. And I'm going to print this on the AD5X today because I'm going to use 2 different filaments just for effect, just to play with different filaments, just to see how they turn out. So I'm going to come up here, make sure that your printer is selected correctly. Add from my downloads today, bolt and nut, open. Single object with multiple parts, I'm going to say no. So then I'm going to move this one over. It didn't want me to put that one there. So there's the nut and the bolt. And again, I have the FlashForge AD5X selected, and I'm going to come up here and change this. In 2, right now, I have orange PET G. Orange. And I have PET G selected here. I have it labeled as black because it's a preset of mine for a temperature of 255 degrees because that's where I'm finding very consistent flow and good prints, is 255. So they all say black right now because it's just one preset that I saved. Number 3 is not TPU anymore. That is also going to be PET G. And I'm going to change that to green. Now I want to, let's say, just print down here. You have global in process. You have global or objects. I'm going to go to objects, select the nut, change filament, and I'm going to do the nut in green. I'm going to move that over a little bit, and there's a very specific reason why, and I'll show you here in a minute. The nut, or the bolt itself, I'm going to right click, change filament, go to 2, which is orange, and as you can see, now I have an orange and green stud. Now the AD5X is a 4-color changer, so they all 4 go to the same nozzle. It'll retract one, put in the next color, retract that one when it's done, put in the next color, and it'll just keep rotating through those 4 colors as much as you want. And that's where you see this tower right here. This is called a prime tower. And what it's doing is it's keeping everything at the same level so that it can purge out the material. One of my prints just fell apart. It's going to purge out all the material from the nozzle in there and make sure that it's not really mixing colors between the 2 parts if I print this as a normal sliced print. So we're going to go back to global here, and then go over to others, and right here we have print sequence. Right now it's in layers, so much like this stack of paper, this is how the 3D printer prints, is in layers. Page of paper by page of paper by page of paper by page of paper. That's how this works. So in order for a 3D printer to work, it has to stay on that same level. And if you have multiple color changes, it's going to come over and make sure that it's changing colors to do that part at the same level on Z. So I don't want to waste that much filament, because when you are doing multiple colors, these purge material out to make sure you're not mixing colors. And every time it does that, it just essentially poops the material right out the back. And it's just wasted unless you have a recycler and a filament respooler and everything, which I do not. So I found a way to avoid the multiple color changes and the overuse of extra filament. I don't like to waste filament if I don't have to. So if you come down here into others, you have print sequence, and it says by layer. That's where it would just stay on Z at the same level and constantly be changing colors. I'm going to do this by object. And it's going to say we suggest using auto arrange to avoid collisions. Right here, as you can see, there's a blue, whatever color that is, circle around both those parts. That is where the actual head of the printer has to be able to move without colliding to the next part over. So you have to make sure that you're clearing that. And I can just come over here, select this one, and let's go. Okay, well, now it won't hit. Now it's no longer giving me an error. If I slice that right now, this is a total printing time of 18 minutes and 29 seconds with this setup and 2 filament changes. That is it. But if I go back to by layer and I reslice it, that is now a total printing time of 1 hour and 9 minutes with a total filament change time of 32. And every time that it does that color change, it throws material right out the back that it doesn't use. And that's money thrown in the trash can at that point. So I do by object right now. Saves money, saves time, saves a lot of time, over almost an hour. Strength, I am going to do 4 wall loops because that'll give me the strongest stud without wasting too much extra material or anything. But more walls on a stud like that will add strength. So there's a wall, there's a wall, there's a wall, and there's a wall. So there's my 4 walls. The infill is only filling in right here in the very, very center. And for a test, that's going to be strong enough just to show that it works. We're going to slice it, send it over to the AD5X, and then watch it do its thing. Alright, here we go. Fresh on the build plate. If I tilt it too much, I think the nut's going to fall off there, but oh, they're both loose now, so there is the bolt. The nut isn't loose. There's the nut. Without touching them, I'm just going to see if it works. And sometimes they are tough to get them started the first time. It works. Simple, quick design using Onshape. If you're ever in a pinch, you got a 3D printer, I need some bolts of this size just to do something small. I'm not saying bolt your truck tires on with 3D printed studs like this, but I am saying this will get you by and can work in a pinch for certain things. Now, because this all printed standing up, Z layers were across it, so the weakest portion of this bolt is going to be if you put downwards pressure across it. You can do it with any size you need. I haven't gone down to like 1/8-inch size studs or anything like that because that is very tiny and I'd have to change the nozzle probably to a 0.25 millimeter for the details. But this stud right here printed almost perfectly. Doesn't look bad for being just a printed piece. Right away. 20 thousandths oversized on the nut, 375 for the diameter of the stud. Threads right in, it'll get you by, something to get you started at least with designing your own threads. So if you got a 3D printer, go try it for yourself. Make yourself one of a custom size. You don't always need to rush out and go to the store. That is one thing that I love about this 3D printer. During Christmas time, my wife and I went shopping for entirely too long for me to be in a store. We got home, she said, crap, I forgot the Christmas ornament hangers. We need to go back. This is my friend and saved me a trip to the store again. So, thank you all for watching. I'm going to get back to designing. This works. I didn't drink, and I hope you can do the same. Thank you all for watching, and we'll see you on the next episode.